We are still in this series, all right? We are looking at duality of light, okay? Now, the first person that spoke about duality of light is Albert Einstein, okay? Where he used the photoelectric effect, which we already explained as one of the evidences that light can behave as a particle, okay? Now, after that, a man known as Louis de Broglie, a man known as Louis de Broglie was the one who advanced on these theories. Okay, now this man said, okay, before I move into that, I want to speak to you about de Broglie. Okay, de Broglie was one who actually hypothesized that after studying Einstein's work, besides that, yes, that the Earth or the planets, as case may be, the universe is always in line to be in symmetry. Okay, what that's supposed to mean? He said that Albert Einstein was actually talking about light, particularly, but him himself, came up with the idea that that not just light, that all matter, can also behave as a wave and also as particles. Okay, so if light can behave as a wave and also as a particle, it means that all matter can also do the same. Am I communicating? So the wave of any matter, according to de Broglie, is known as the Broglie wave. Okay, this is the wave of a matter as to the movement of the particles of the matter. Am I communicating? So whenever we are talking about the Broglie wave, we are talking about the wave of a particular material, okay, in respect to its particles. Are you getting my point? Good. Then wave of a particle, as case may be, of light, of particle, can or will also have what we call wavelength. Okay, what is wavelength? If you go to our videos, you watch where we treated wave, you find out that when you say wavelength has to do with the distance between two successive crests or troughs. Okay, so when I have something like this, okay, the wavelength is here. These are called a crest. The upper part are called a crest, okay? Then the lower part are called a trough. So the distance between this and this is known as wavelength. The distance between this and this is another wavelength, and all that. Then this also what? From here to here is another wavelength, a negative wavelength. Then this one is also what? Another what? Wavelength. Am I communicating? So that is for what? The Broglie wave, okay? Now, the Broglie wave is actually talking about the wave of a particle of matter in respect to their particle. Am I communicating? Good. Now, I want to talk about the Broglie wavelength. The Broglie wavelength, the Broglie wavelength has a relation which says that wavelength is actually wavelength lambda is equal to Planck constant, the ratio of Planck's constant all over mass of the particle times velocity of the particle or photon. Are you with me? So this is the Broglie wavelength, where you say that lambda is equals to h. This is h, which is Planck constant all over mv. Remember that momentum rho is equals to mass times velocity. So anywhere I say mv, I can change it to the momentum of the particle. Am I communicating? Okay, so how did we arrive to this formula? How do you arrive to this formula? Now look at the board. you know, a theory known as Planck's theory or Planck's quantum theory, Planck's quantum theory, okay. The Planck's quantum theory states that, the energy possessed by a photon or a quantum, okay. Photon means the packet of light, okay. The energy they possess, okay. So the energy possessed by a quantum is direct proportional to its frequency. Am I communicating? So when you introduce this is known as the energy, okay, direct proportional to what? To frequency. Of course, you know that frequency is actually the number of oscillation of a wave, in 1 second, okay. So then you're going to have that E is equals to a constant H, then F. So this is what we call, Planck's quantum theory, which possesses this relation. Are you with me? Now, a man known as Albert Einstein actually studied, Einstein considered the the photon, okay, the photon as a mass, okay, the photon of the particle in mass. So he actually said that, according to Albert Einstein, he said that the energy, having considered the photon in form of mass, which means we have the value of the mass of the photon or of the particle. Am I communicating? So the particle, the photon now has been measured in form of mass. So if we have that the mass of the photon is known, am I communicating? You observe that the energy possessed by that photon, okay, is actually equals to the mass of the particle, which is the mass of the photon, times the velocity squared. Am I communicating? Here the velocity is seen as c, so you're going to have that, or E is equals to mc squared. Are you with me? Now I have equation 1 here, and I have equation 2 here, if you look closely, okay. Now, and if you look closely, you find out that in these two equations we have something in common. This is energy, and this is also energy. Energy is equal to HF, and energy is equal to mc squared, okay. And we are talking about energy of a photon and also energy of a what? Of a photon. But here we are considering the frequency, that is in quantum theory. We are considering the frequency. Then here we are considering the mass. Am I communicating? So equating the two, since they are the same, equating equation 1 to 2, okay, equating equation 1 to 2. Are you with me? Are you there? So equating equation 1 to 2, you found out that E, let me call this one E1, let me call this one E2. E1 is equals to E2. If E1 is equals to E2, are you there? You found out that E1 is also equal to HF. Of course, if E1 is equal to E2, it means that E2 is also equal to mc squared. So these and these are the same, okay. Now I'm going to have that HF is equals to mc squared. Now I want to make mass subject of the formula. Are you with me? So here we want to make the mass subject, okay. So you're going to have that mc squared is equals to HF. I didn't change anything, okay. Then if you look at the body, you say, let me call this one equation 3. You find out that here we want to make m subject of the formula. Then automatically anything that is disturbing m must be divided by the both sides. Am I complicated? So that m will be what? Will be free. Okay. So, and what is disturbing m here is c squared. So I'm going to use it to divide the both sides. So c squared cancels c squared, and have that m is equals to hf all over c squared. Are you with me? So if you look at here, you found out that I'm already having equation 4 here, okay, from these two equations, right? So here it means that the mass of the photon, okay, is actually equal to the Planck constant times frequency of the photon divided by the divided by the velocity, was the velocity of the particle being squared. Am I communicating? So from here we ought to wipe this side, okay. From here if you have that m is equals to hf all over c squared, am I communicating? This is m. Then I want to look at particularly only on the momentum of this particle that has this mass. Am I communicating? Okay, so you found out that in that photon the momentum is equals to m times v, which is what? M times c. Here I am using c as velocity. All right, so m times c will give me what? The momentum of the particle, you know, particles in that in a photon. Am I communicating? So here you have to note that, you know, since the velocity of the particles of the photon is constant. Are you with me? It means that, you know, my momentum is actually equal to, my mass is hf all over c squared times my velocity is what? C, because it's a constant. Am I communicating? For all the particles in that photon. Are you with me? So you're going to be having that here. You're going to having that momentum is equals to hf all over c squared is c times c, then times this constant velocity. All right. So here the c will cancel the c. Okay. Let's move over to this side. Then we have that momentum is equal to hf all over c. Are you with me? So here we have that what? Momentum is equal to hf all over what? C. So here I have equation 5. Are you there? Now let's go to this side of the board. Are you with me? Follow suit. Now if P, which is momentum, is equal to hf all over c, are you with me? I want you to remember that from wave, we have that velocity c is equals to f lambda. Are you with me? Yeah, you know, where, you know, the law told us that the relationship between velocity of your wave, wavelength, and its frequency, okay, where the law told us that the velocity of your wave is direct proportional to its frequency, okay. Removing the sign of proportionality, we introduce the constant there, which is the lambda. Are you with me? So if this is the case, it means that anywhere I see c, I can put f lambda. Are you with me? So I'm going to be having that momentum is equals to hf all over, let me call this equation 6. hf all over c is what? F lambda. So I'll put f lambda. So here f will cancel f, and I have that p is equals to, are you there? P is equal to h all over, that is Planck constant all over lambda. Am I communicating? So this is lambda, then this is Planck constant. So if that is the case, I want to make the Broglie, because all these were derivatives of the Broglie hypothesis. Am I communicating? The Broglie dualistic hypothesis. Am I communicating? So here we have that momentum is equals to Planck constant all over lambda. So if I cross multiply, I'm going to have that, momentum times lambda will give me momentum lambda is equals to 1 times Planck constant is h, which is Planck constant. So dividing this by momentum, dividing this by also momentum to make the wavelength, so the formula, the Broglie wavelength, okay, I'm looking at the Broglie wavelength now, I'm going to have that wavelength is equals to Planck constant all over lambda. All over momentum. This is also equal to h all over mc or mv. Okay, so you find out that what's mv or mc. Okay, let me use mv. Okay, found out that what we wrote here, has been derived, at this point. So this is what we call the Broglie wavelength. Am I communicating? So, make sure you take your time, go through the video again and again. You don't need to cram anything, okay? We all started from the fact that the Broglie have a wavelength which is equal to Planck constant all over mv. So we move that direct to Planck constant, because since you say Planck constant, where is it coming from? It's coming from Planck's quantum theory. Okay, now we have the Planck's quantum theory, okay, being stated, which where he said that energy is actually equal to is directly proportional to frequency. Am I communicating? That is E is equal to HF. Okay, I think we have already wiped it here, wiped it off from here. Okay, so from there we move into Albert Einstein energy, where he also explained, hope you're following, he also explained that if the photon is measured, if the particle is measured in mass, okay, if the particles of the photon, or if the photon is seen as a mass, okay, that energy is equal to mc square. Am I communicating? Mc square. So equating the two energies, equating that E is equal to HF and also mc squared, okay, we will make the mass of the formula, okay, the mass of the formula. So here you are looking at the mass, okay, so you have that what mass is equals to HF all over c squared. So having known that, this is the mass, okay, we can now move into, calculating the momentum of the photon. So momentum is what? Is a product of mass and velocity. Am I communicating? So if the velocity, since the velocity of particles in photon is constant, then automatically we have that what? That this HF all over C times C, will give you the momentum. So where we, used and manipulated and cancelled this, okay? After calculation, we found out that P is equal to HF all over C. Are you getting my point? Then from there, we move into, okay, moving to the fact that, from wave, that C is equal to F lambda. Changing anywhere you see C with what? With F lambda, we found out that what? That P is equal to H all over what? All over lambda. Am I communicating? Because the frequency will cancel the frequency. Are you with me? The remaining Planck constant and this. Am I communicating? Making this sort of the formula, we have that what? H is wavelength is equals to H all over what? All over P. Are you with me? Then from there, we found out that what? That momentum can also be changed to what? Mass times velocity. So that is where, how we drive this formula. This formula, this wavelength is known as de Broglie wavelength. Am I communicating? So we are looking at the Broglie wave. Am I communicating? So I'm going to be looking out for the next episode on this duality of light on physics. Thank you.